All right, this is going to be screencast 1 for RTI over Unit 4 test. So we're just going to go over the questions and answers. I'm actually not going to mark anything because I expect you to listen because I've had some problems in the past with people just kind of forwarding through and seeing what the answers were. So you have to actually listen and go through it with me. Number 1 says, what is the acceleration of the car between 2 and 5 seconds? Well, first of all, you need to see that the line is perfectly straight. This is a distance versus time graph. And when you have a nice straight line, that means that there is no acceleration whatsoever. But I can prove this in another way also. From 0 to 1, I go 5 meters in 1 second. From 1 to 2, I started at 5 meters and I wound up with 10. That's also 5 meters in this second. 5 meters in this second, 5 meters in this second, 5 meters in this second, okay? So there is no change in speed, so there's no acceleration because I'm going 5 meters per second the whole entire time. And I can tell that not only by doing the math, but because the graph is a straight line. Number 2, what is the average speed of the car after 3 seconds? Okay, after 3 seconds, that is a time interval of 3 seconds. You've covered a total distance of 15 meters. Speed is distance divided by time. So that's going to be 15 meters divided by 3 seconds, and you're going to get 5 meters per second. Okay. Number 3, a roller coaster containing 3 cars is accelerated at 10 meters per second squared before it comes to an abrupt stop at the end of the ride. The mass of one cart is 300 kilograms. How much force was exerted on the roller coaster to bring it to a stop? Well, the thing that's most commonly missed is the fact that there are 3 cars and one of them weighs 300 kilograms. But you've got 3 of them. So 3 times 300, you have a total mass of 900 kilograms. And remember, I will write this down. Remember that force equals mass times acceleration. Your mass is 900 kilograms times an acceleration of 10. 900 times 10 gives you D, 9,000 newtons. Number 4, a force that will work against motion in every situation. The normal force is not an appropriate answer. There is something called the normal force, but we didn't talk about what it was. Weight is a force that's always present, but that always acts straight down towards the center of the earth because it's associated with gravity. Friction is the one that we talked about that always works against motion. It always works to slow down and eventually stop an object. So the answer for number 4 should be J. All right, so real quickly, number 1, the acceleration of the car was 0 because the line is straight and it's going the same speed the whole time. Number 2, the average speed of the car, speed, remember, was distance divided by time. The total distance covered in those 3 seconds was 15 meters divided by 3. 15 divided by 3 gives you answer G, 5. Number 3, 9,000 kilograms times 10. 900 kilograms times 10 gives you 9,000 newtons. And number 4, the answer was friction. All right. Number 5, you're riding in a vehicle with a coffee cup on the dashboard while traveling at 30 kilometers per hour. The vehicle makes a sudden stop to avoid hitting the car that stopped in front of it. What would happen to the coffee cup? Well, a very simple demonstration is probably the easiest way to show you what's going to happen to the coffee cup. So there's my sudden stop because it's going to run into the little froggy pad. The red bead represents my coffee cup, and obviously the orange car is my car. So, okay, that's not the greatest stop in the world, but hopefully you see that the bead will continue to move forward. Okay? All right, so what's going to happen to the coffee cup? That's our bead. It continues to move forward. It's not going to go backwards. It's not going to stay stationary, and it's not going to fly straight up. It is going to go forward. When the car suddenly stops, the objects in the back seat, just like the coffee cup, are thrown forward. This is due to inertia. because remember that objects in motion tend to stay in motion. Okay, that is the law of inertia. Objects in motion tend to stay in motion unless acted on by an unbalanced force. So the force that stopped the car was not stopping the coffee cup or the bead. So the bead in the coffee cup continued to fly forward, just like anything in the back seat that's not strapped down is going to fly forward. Okay. Number 7, which of the following statements concerning forces is true? Balanced forces cause objects to speed up, slow down, or change direction. That is not true. That would need to say unbalanced forces cause objects to speed up, slow down, or change direction. So it's not A. When forces are balanced, objects cannot be in motion. That is not true either. Objects can be in motion when forces are balanced. It's just they're not going to change the way they're moving. They're going to have to be moving at a constant velocity. C says unbalanced forces cause objects to accelerate. That is true. Unbalanced forces cause objects to speed up, slow down, or change direction. And then D is not true because we've talked about the fact that friction is a force that always acts to slow something down.